Hey kiddos, hope you're doing well. In this video I'd like to introduce you to just some notation and perhaps towards the end a little bit of an understanding of relations and functions. So here we go. Lots of different ways to note sets. And so let's just start with a specific example. And let's suppose that's a number line. And over here, let's say here's the point, I don't know, -2. And somewhere over here is the point 5. Okay. And let's suppose I want all the numbers um, in between, so greater than, and this is important, greater than -2, and all the way up, including 5, right? So I really want this open circle at -2, and then bam, up to 5, right? That's the interval I'm looking at, right? So all the numbers greater than -2, up to and including 5. Right? So there are a couple different ways to write that. The first way is simply with interval notation. Right? Now in interval notation, we start with the left quote-unquote endpoint. Right? And since -2 is not in this set, I'm going to put an open bracket, which means at -2. Right? So this is the number I quote-unquote start with. Right? But it doesn't include -2. It's everything to the right of -2. Right? And then comma, and then all the way up to 5. Now because 5 is included, because 5 is part of this interval, right? 5 is an acceptable number in that set, then I want to create a closed bracket on the right, right? So the closed bracket means that 5 is included in the set. The open bracket at -2 means -2 is not included in the set. Okay, that's interval notation. Another way of writing it would be to write as such. We could simply write, well, x has to be greater than -2, right? But what does it also have to be? Oops, not that. It also has to be less than or equal to 5, right? Greater than, so this piece means x is greater than -2, and it's called a conjunction, x is also less than or equal to 5. Right? Now we can make that look a little fancier using what's called set builder notation. So that piece is going to look like this. I'm just going to add a little bit. So these are our, whoops, nope, that's not what I want to do. This right here, there's our brackets, right? And brackets means we're creating a set. So I want to say the set of all x's such that, and now I keep the same interval notation, inequality notation. X is greater than -2, but also x is also less than or equal to 5. Okay. So these are primarily the two different ways we'll note sets as we move through this course, right? Either interval notation or set notation. I believe some people call it set builder notation, right? And because it's a set notation, that's evidenced by these brackets. Okay. So two different ways of saying the same interval, right? From -2 all the way up to and including 5, but not including -2. Yes, including 5. Okay? Great. So the next thing I want to think about is what on earth, and this is a common strand for this course, but not so much relations, and we'll talk a little bit about that, but more importantly functions, right? And this idea of a function is a key idea in mathematics, right? We're going to study lots of different types of functions in this course. So first let's kind of think of a Venn diagram, right? So here's all the relations, right? And a relations is just some sort of rule between two sets. So a relation is any sort of mapping of one set onto another, right? Nothing more, nothing less. Right, so we have this notion of two sets, and a relation is just mapping or pairing each of the elements of one set onto the other. Right, now, if we're thinking about Venn diagram, a certain type of relation is called a function. Right, and a function is a certain type of relation. Whoop, get rid of that. Sorry. And so kind of thinking about a Venn diagram here, here is the set of functions. Right? And so what we have here is a function, if you recall, is a relation, which means it's a mapping of one set onto another, such that for each input there is one output value. Hey, how are you, Margaret? Good. Right? So for each input there's one output. So that's what distinguishes a function from any old relation, right? And you probably remember this notion of a domain, or all the inputs. So here's my set of inputs, which we call the domain. And then all those suckers that live in the domain get paired up with all these pieces over here, the other set, which is called the range, the outputs. Right? So if it's a relation just takes all the elements in the domain and pairs them somehow onto elements in the range. A function takes all the elements in the domain and pairs each one of those with one unique output value in the range, right? So functions work from set domain to the set range, right? So the one question I have for you to consider for homework is this. Let's suppose the function y equals, insert x squared. So I want to think about the function y equals x squared. Right? There it is. Right? Here's what it looks like. So the question I want you to think about is, using set or interval notation, what is a domain, all the input values, and using set or interval notation, what is a range, all the output values for this function. And it is a function. Okay? Think about that question. Come in with some answers and questions tomorrow.